Hello, Sanam. Hello. Concave or converging because why are they converging? Because they converge parallel rays incidenting on the mirror. Okay. So concave or converging. Let's also have a convex mirror. So here convex or diverging, and the coated surface curves inwardly, the reflecting surface curves outwardly. Now with convex, the pole is here. Measurements, okay, on the mirror or around the mirror are always taken from the pole. Okay, so if this is the pole, whenever you are measuring, taking any distance, the object is always placed in front of the mirror. So objects would always be here, being it concave or convex. Okay, so objects are always placed in front of the mirror. Objects are always placed in front of the mirror. So the object distance here will be from the pole to the object. The object distance here, in the case of the concave, will be from the pole to. So generally, what all that we are saying is that measurements are taken from the pole. Please, are you with me? Are you with me? Measurements
Yes,
are always taken from the pole. So that is it. This line is the principal axis, just as we saw here. Okay. Now let's look at what we mean by these points. AB is the width of the mirror, which we also call as the aperture of the mirror. Then the center of the mirror is the pole. The principal axis divides the mirror into two equal parts. Now there is this point F, which is known as the principal focus or the focal point of the mirror. Now let's understand what we mean by the principal focus. Experimentally or practically, it is noticed that whenever you have paraxial rays, and what is paraxial rays? Paraxial rays are rays that are very close to the principal axis and then parallel. So they are parallel paraxial rays are parallel. What you would say are parallel, but maybe they are parallel. Okay, parallel lines, rays, or let me put rays that are close and parallel. Parallel to that are close and parallel to the principal axis. So parallel rays are parallel rays that are close. Okay. And let me reconstruct this. So parallel rays are rays. Let me put rays that are close and parallel to the Okay, so paraxial rays are rays that are close and parallel to their principal axis. Principal axis. So all that we are saying is that if you draw or incident on the mirror, rays that are close, very close and parallel to their principal axis. Rays that are close and are parallel to the principal axis. These are what we call as paraxial rays. These are what we call as paraxial rays. So let me do it for the convex mirror. Rays that are close and are parallel to the principal axis. These are what we call as paraxial rays. Please, are you okay? Are you okay? So when you have these rays, which we call as paraxial rays, whenever they hit the mirror, they because this is a convergent mirror, all the rays, parallel rays will converge at a point. All the rays will converge at a point. Okay. Now, experiment. Then when we look at it for convex mirror, it will reflect. It will reflect because or diverge. Let me say diverge better. Now, experiments have shown that whenever paraxial rays hit the mirror, they all converge at a point on the principal axis. Okay, for concave mirror. This point where paraxial rays converge, okay, on the principal axis after reflection, when it comes to a concave mirror, it's what we call as the principal focus. It's what we call as what? Principal focus. Please, are you okay? Give me feedback. Sana Menko, are you okay?
Yes, please.
Okay. Now, so let's look at the definition for the principal axis of a concave mirror. So the principal focus or focal point of a concave mirror is a point on the principal axis where paraxial rays converge after reflection. Okay, so the principal focus or focal point of a concave mirror is a point on the principal axis where paraxial rays converge after reflection. Now, I want one of you to tell me about the principal focus of a convex mirror. What do you think will be the principal focus of a convex mirror? If this is it for concave mirror, what do you think will be the principal focus for a convex mirror? Anybody to attempt? Just give it an attempt. Anybody to try? Adwa, Abina, Davina, Deborah, Irene.
Yes,
Anybody to try?
please, the point where the parallel set of incident rays meet at a point after refraction.
We are Irene, nice attempt, but we are talking about reflection. We haven't looked at refraction yet. Okay, Irene has given an attempt. Anybody else? Sadam, can you try? What is the principal focus or focal point of a convex mirror?
Please, I don't know.
Okay. All right, then let me handle it. Irene, nice try. Now, convex mirror diverges rays. Okay, Adwa is trying to say, Adwa is a point on the principal axis where parallel rays diverge after reflection. Adwa, nice try, but you are missing something. You see, for convex mirror, it diverges rays, parallel rays, okay? Now, because the rays are diverged, in front of the mirror, hardly would they converge at a point. Okay, in front of the mirror, because the rays are spread out, hardly would they converge in front. But they will appear to have been diverged from or converge at a point behind the mirror. You see, let's trace back the path of the reflected rays. If we trace the reflected rays backwards, each one, we get all of them because I didn't draw it well. That's why it doesn't look. So this is a point behind the mirror where the diverged rays appears to be diverged from. These reflected rays, they all appear to be diverged from this point. And this point, this is what we call as the principal focus or the focal point of a convex mirror. So how do we define the principal focus of a convex mirror? It is the point on the principal axis where rays that are paraxial rays appears to be diverted from. This rays appears to be diverted from this point. Please, are we fine? So it is a point on the principal axis Irene, I'm coming. I will take it over. But is it better? Can you hear now? Irene?
Yes, please, but I can't see the board well.
I'll take a shot and send it. So it is a point on the principal axis where paraxial rays appears to be diverted from after reflection. So it is a point on the principal axis where paraxial rays appears to be diverted from after reflection. Please, is it okay? Is the explanation okay? Hello, are you there? I hope it's okay.
Please, can you go over again?
Okay, so let's take it from concave mirror. First, I said paraxial rays are rays that are close and parallel to the principal axis. They are so close. What I've even drawn cannot well explain it, but paraxial rays are very close to the principal axis. So when you focus paraxial rays onto a concave mirror would converge parallel rays. Okay, it will converge parallel rays. Now, after reflection. So when the paraxial rays hit the concave mirror, because they are all paraxial or are close and parallel, they will all be converged at a point on the principal axis. So this point where rays that are close and parallel to the principal axis converge after reflection is the principal focus of a concave mirror. I hope this is okay. Now, this is a convex mirror. Let me draw it again. A convex mirror. There's a coated surface. Let's draw a line to indicate the principal axis.